right, let's go. Okay, so I did want to start class today just like a little bit reflecting on where we are in the term, which is real far. We're all the way down here. And like kind of a lot of this stuff down here is like a little bit fake because this assignment is going to go out and then mostly you're just working on that assignment. That assignment has all of the course content on it, which means everything after basically like this assignment is like free bonus content. Like I'm going to show you things that are useful, right? But I think there's like one thing on the final that gets assessed out of here, and that's it. So like this is going to be extension content. This is planned to be some AI stuff. This is extension content. That's extension. So like we run out of course content in like just a few weeks. Okay. So there's like 3 weeks left of like full content, and then 3 weeks of like bonus. Okay. You are currently working on Breakout. Breakout is, and I think I've said this before, like at least to me, the most academically interesting of the projects this term. So definitely do your level best on Breakout. I think you can learn a lot from it. I think it's a really productive thing to do. Versus the other assignments in here, I think I had the most fun doing Breakout, personally. Your mileage may vary. After Breakout, so at midnight tonight, like take a break, take a walk, like once you get Breakout in. And then we're basically starting to work on Image Shop already because problem set 5 is used on Image Shop. So you just start on problem set 5. When you're good with that, you'll have made good progress on Image Shop. So you'll be in a good place. Then there's no more problem sets. There's one more midterm, which will be as similar to the previous midterm as I can. I'm still coming up with good ideas for that. I think I have some things. So hopefully that'll be like not awful. It won't be awful. It'll be great. Okay, and then just the two last projects, and these are both 2-week projects, so you'll have a little more time on them. So that's where we're at. So you are like very far along in the term, in this class at least. And I just wanted to let you know that. This means it's time to show you something really cool. I think it's really cool. If you don't think it's really cool, that's fine. But there's one specific, I don't know, way of feeling that I always feel when teaching PGL, which is that the graphics on computers don't look like the graphics made by PGL anymore, and PGL is like, I think, older than I am. And so if I just like go to like a website, does anyone have a favorite website that I can show in class?
YouTube.com.
I do love YouTube.com. So, do you notice how, like, not everything here is a rectangle? And there's, like, different shades and colors? Anyways, to me, PGL, like, doesn't look like how I expect computers to look, because I'm not used to just, like, having a circle on a white background. So I'm going to show you how to make some, like, different kinds of backgrounds, basically, and colors and stuff. Okay. Breakout's done tonight. You should be done, but... do you want to ask me anything about Breakout? I will do whatever you want if it will help you, yes.
I keep having this weird thing because of checking all the four corners of the ball when it bounces on the paddle, it like gets stuck and like wiggles around.
Right, okay. This might be hard to demonstrate. We're close here. So here is, do you remember this? That ball's not moving currently because the mouse move hasn't started yet. And I think when I unpause it, it goes. Okay. So, and you say it gets stuck, right? I'm trying to think if I can get this stuck. I'm going to slow down the timer so I can get stuck more easily. Okay, so, there it is. Okay. So if something catches exactly on the corner of the ball, it keeps going back and forth, right?
Yeah.
One way to get around this, and this is what I recommend, is checking to see if there is going to be a collision where the ball is moving to, rather than checking to see if there is currently a collision. And the way I would do that is, I think, let's see, time func is where we do the collision check. So here's my collision checks, right? He's bigger or bad highlights. I'm checking walls, and then I'm checking to see if there's an element at that location. I did not have to do that. I could have updated the location first, and then done the collision checks, okay? So this simulates seeing where the ball is going to be, then seeing if there's a collision.
I
Then,
think that's what I'm doing already, but it's still.
okay, there's still one more trick. So one more trick. If you're in here and had a collision, you have to get the heck out of Dodge, right?
Yeah.
And so what we actually do, you already went into the wrong place. So you have to go back to the correct place and then go back in the other direction. So you move really far away from where the impact site is. And you do the same thing down here. Okay, so now if this thing even gets close, look, see, it's bouncing all the way over there, right? It still gets stuck, but that's getting stuck because I can move it. It won't get stuck on the paddle. And it won't get stuck on bricks either. Let's see. Boink, bonk. I'm also not checking all four corners because that would be a lot of code, right? So this is my recommendation for how to deal with this. This will go probably right in Discord right now. But calculate where the ball is going to be. See if there's a collision at that location. If there is, bounce before you get to that location. This also usually prevents the breaking multiple bricks problem. So sometimes if you come in incident at an odd angle on a brick, you break like 3 bricks at the same time. I don't know if that's like against the rules or something. I thought it was discouraged. This prevents that because this triggers a bounce before it happens. Wow, this game is so much easier when you turn the speed down 10x. To make sure you understand course content better today, I'm going to start talking at 1/10 of my normal speed. Is this class? Okay. The following checks for collisions before they happen instead of after, and generally prevents balls getting stuck on paddles and or bricks, I think. Check it.
How would you include checking to make sure that it's not the paddle that you're colliding with when you do it like this?
Oh, so I have I don't remember exactly what I did. Just don't have my solution with me right now. I'm pretty sure what I did is I did the get element at checks. And I just check if it's the paddle, and if it's the paddle, I always do a specific kind of bounce. I like always do a vertical bounce.
Yeah.
And then if it's anything other than the paddle, I do like the brick handling thing. So those were basically, I got the element, and then rather than just checking if there was an element, I checked if it was the paddle.
Okay.
So these don't have to be in the same line, right? Because
Yeah,
this is
that's
the
what
wall
I was
check.
gonna say. I think I have mine separate.
Yeah, and I think you do need them separate for breakout. Because you would do like, what am I doing? You'll have a check like this. You'll probably have something called like gw.paddle or whatever you call it. If this happens, you definitely do a vertical bounce. What is a vertical bounce? gw.vx, which is the x velocity, right? Is x vertical or no? Y? Yeah. And you want it to be going up, which means it's negative. So that's negative absolute value gw.vy. or something like this. So it forces a vertical bounce. What does this also mean? This means if you get stuck, like if you come in at the bottom of the paddle, it pushes you up because it's just forcing vertical motion the entire time you're in the paddle. I think I can demonstrate this. And this is going to look weird, but I think I can show this. So it starts moving. It's going down. Okay, I want it to be going the other direction, and then it will come incident on the paddle. So I can stay on top of it and it keeps moving up. Or it can bounce. Oh, I missed it. Boing. But if I overlap the ball while it's going up, it doesn't do anything, so this always causes the ball to go up if it hits the paddle. And that prevents it from going back and forth in the paddle. This prevents getting caught on the paddle when you bounce on the bottom of the paddle. It's possible that this is unintended gameplay mechanics, because it might be the case as a game designer you think if you hit the bottom of the paddle you should like die or something, which is reasonable, like it bounces back off the screen. So like you can make up your own mind about that. And I think another way to do this is you can only do these checks on the bottom of the ball. So you don't have to check all 4 locations. You just only check the bottom to see if it's incident with the paddle. That's getting to be like more code than I'd want to write, so I just check all the corners, but... Okay. Those are great questions. Do you have any other great questions?
I think that's all of the questions.
I'll answer questions like this all day. These are great. And anyone else have any great questions? We'll also accept bad questions. We'll accept medium questions. Okay. Anyways, y'all are awesome. You're asking great questions. You're asking the exact right questions. So, good job. Yes, worry about PS5 when you want to. You probably want it to be done and be well rested by Monday. So that's how to pace that. It is not a full week worth of work. Okay. Today, I'm going to teach you about pixels, hex codes, string operations, and gradients. I think gradients look cool. We have to do the other stuff to get to them. So, how am I going to do this? I don't know if y'all have seen these like color pickers before. They're pretty common in like web development. I think maybe the graphics designers do them. This is not mine. This is completely yoinked. So someone else made this, and I don't even know who. But if I click somewhere on this grid, I do a clickaroonie, right? It changes the color over here, and it also changes this text. And so what's this text representing? Well, I'm going to call these hex codes because they are numbers that are expressed in hexadecimal, which is somewhat of a novel number system that is used frequently in computing. But if there's any color you want to create, you can always just go to this color picker app and click around and see what hex code it corresponds to. So, what are hex codes? Let's look at an example, and I'm going to use the example of X0F030. I said X instead of hashtag. So hashtag is just the prefix to denote it's a hex code, so that's 0F0300. This is the same as a red brightness of 15, a green brightness of 3, and a blue brightness of 0. And that doesn't make any sense. So how are we going to make that make sense? Well, one way to express color to a computer is computers have within them, basically at every point on this screen or in that lamp, right? They have the ability to produce red, green, or blue light, and they can do it at varying levels of brightness. So, all of nominally, right? I think it's a little more complicated than this, but nominally, the way all colors on a computer, and like maybe you could argue do this like with paint, I wouldn't do that, but like on a computer, is you decide how much green brightness, how much blue brightness, and how much red brightness you want. And if you have a lot of red brightness, so if you have a red light, and a lot of blue brightness, you get this color, which I would call magenta. You can call it whatever you want. If you have a lot of red and a lot of green, but not a lot of blue, you get this color, which I would call yellow. If you have a lot of green and a lot of blue, you get what I call cyan. And if you have a lot of all three, you get white. And if you don't turn any of them on, you get this black color, right? So that's how I think of colors. There are other ways to think of colors, and this is not, I guess, how my eye perceives color exactly. But for me, computers are easier to understand than me, so I think of colors in this way. So, what am I going to do with this information? Well, for computers, and for PGL, and also for web development, generally speaking, we are going to use the hexadecimal number system to represent the brightness of a color. Why are we going to do this? Well, there's a historical reason, and you don't have to worry about it, but it is just something that's going to happen to you. Hexadecimal is similar to our number system. I think of our number system as decimal. It is base 10, which means I count up to 10 and then I add another digit. And I think that's because I have 10 fingers. So I think if we all had 16 fingers, we would already be counting in hexadecimal. Computers basically have 16 fingers, and that's how they count that way. So the name hexadecimal just means 610 base 16. So this is the way I think of counting in hexadecimal. When I start counting, I say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The next number I say is not 10 because I'm going to get up to 16 values before I go to having a second digit. And so usually we just use letters to note that. So I say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And that's A, B, C, D, E, F. Those are the 6 additional characters I need to represent values. So A is in hexadecimal is the same as 10 in decimal. F in hexadecimal is the same as 15 in decimal. And when I say 1, 0 in hexadecimal, that looks like a 10 to us, but that means the number 16. I usually refer to these as decimal and hexadecimal, or base 10 and base 16. There's one confusing thing, I think slightly confusing thing about this. Oftentimes my impression is when people say decimal number, they mean a number with a decimal point, not a number in the decimal number system. That's fine. I'm just going to try and be specific. So sometimes I'll say base 10 when I don't want to say a decimal number. I will say a number in base 10. But it means the same thing. I'm trying to avoid confusion. And it's just a little bit confusing. Fortunately, there are these things called computers that are like pretty great. And the computers are like pretty okay at dealing with different number systems. So what I'm going to do here, is this all a good size? Well, I'll start typing. We'll see what happens. So we can print out the hexadecimal value of some number. And for example, I'm going to print out the hexadecimal representation. I'm going to say it's the representation of a number because the number is the same. It's still this many. I'm going to print out the hexadecimal representation of this many. Okay? And I type in the number in decimal. And I get 0xa. What is the 0 and x? The 0 and x just represents this number is in hexadecimal. Why is that? Because if I put in 2 times 8, it's going to come back looking like 1, 0, but that doesn't represent decimal 10. So I need some way to represent that this is a larger, different value. If I were to, for example, put in decimal 26, then it would be obvious, the output, that I am dealing with non-decimal numbers because we don't usually put a inside of our decimal numbers. What this means is that, sort of similar to if I have decimal 12, I have a 1 in the tens place, and then I have a 2 in the ones place, so I add 10 to 2, and that gives me 12. In this case, I have a 1 in the 16s place, and then I have an A in the ones place. So that means I have 1 decimal 16 and 10 decimal ones. 16 plus 10 is 26. So this is the hexadecimal representation of 26. If I were to add exactly 16 to this, which would give me 42, No, I'm just, why would I do it that way? Okay. I'm going to add 16 to this, like that. It is going to be 42, but it doesn't matter. By adding exactly 16 to this, I'm going to change this 1 to a 2 because I will have an additional 16. This is the same as if I add 10 to 20 and get 30. So that's going to give me 2a. I want to give you some level of encouragement to play around with this. I'm going to give us sort of a motivating example how to play around with it today. So here are some examples, and we can look at each of these. Let's look at the hexadecimal value equal to decimal 1, the hexadecimal representation of decimal 10, and the hexadecimal representation of decimal 100. It is probably unsurprising that 1 is the same, because those are both less than 10 and 16. It is hopefully a little bit unsurprising that we represent 10 as the number after 9. In the decimal system, 10 is the number after 9. In the hexadecimal system, 9 is the number after, or A is the number after 9. This one might look a little goofy. That looks like, probably to us, decimal 64. It is hexadecimal 64, and you can refer to it as 64. And what does that mean? Well, that is 6 16s and a 4. Which is why it is 100. So, since I have a 16s place instead of a 10s place, I have this many 16s, which gives me 96, and then I have an additional 4. This is quite similar to the stir function, str, that turns numbers into strings. So, for example, if I print hex 10 plus hex 10, this will not perform integer arithmetic. It will just put the two strings together. And that is the same thing as if I turned that 10 into a string. So when you use hex, the hex built-in function in Python, what it is doing is it's giving you back a string that is how you would represent a numerical value. It is not itself a numerical value. So you have to treat it like a string. The same way the string open quote 10 end quote is a different value than 10. And we can represent that in a variety of ways. We can say string of 10 is not equal to 10. This is true. And we can say that it is, that's the wrong quote, equal to this string. That is true. The last thing that you might be interested in doing is you can type in hexadecimal values and print out what they are. So perhaps an obvious thing to do is take what we may think of as 100, the expression 100. We can take that in hexadecimal. What will that come out with? 256. If you are unaccustomed to working with powers of 2, this number may look non-obvious to you. What it is we have a 1 in the sort of hundreds place. This is the 16s place, so this is the 16 times 16s place. So that is equal to 16 times 16 plus, let's see, we can say it is 1 times 16 plus 16, because there's a 1 there. If we put a 2 here and a 2 here, we will get 512 in both places. If we put a 3 here and add 3 times 16, we will get 560 in both places. And if we put a 7 at the end and add a 7 here, oh, I said y instead of 7, I don't know why that is, we will get 567 in both places. This is how the number system works, and you can review this in both directions and get the 237 back by using hex. So this is how you can play around with hexadecimal values if you need to. There will be hexadecimal values that sort of exist around the periphery and image shell, and it'll be worth dealing with them. I just want to show you what some of these numbers look like. So I'm going to run this code, but it's going to look the same to you as it looks here. I'm going to print values from 0x8, which is both decimal 8 and hexadecimal 8. And I'm going to go to 0x12. That is a 1 in the 16's place and a 2 in the 1's place, so that is hexadecimal 18. I meant to do range here. For I in range. And what am I going to print for each of these? I am going to print the string representation in decimal and the string representation in hexadecimal. And I will see the following values. So 8 and 9 appear the same because they're both less than 10. At 10, we begin to see our differences, and we say A is equal to OXA is equal to decimal 10, OXC is equal to decimal 12, OXE is equal to decimal 14, and then OX10 is equivalent to decimal 16. You can always check these things. I guess there's one other thing to show, which is that you can just do these checks as well to see if your understanding is correct when you type it in. Okay, so why did we do all of that? Well, the colors that we were looking at earlier are expressed in hexadecimal, and I want you to sort of understand what type of colors you're looking at. The real intuitive sense I have here is that a lot of times I want a lot of brightness, and a lot of times I want not very much brightness, which means I usually use zeros and Fs, because that's the biggest and the smallest value. Or smallest is 0, biggest is F, right? So we're going to express these in hexadecimal. So what is this? That is F5, that's a lot of brightness. That is 4.9, that's a sort of medium amount of brightness, and that is a 2.7, that is a small amount of brightness. One way to think of this is if I go over to the whitest part, I get all Fs because I have very high brightness. And if I go down to the darkest part, I get all zeros because I have no brightness. If I go to a very red place, which I think is over here, I have a lot of brightness in one place and a lot of darkness in other places. And I think that will still be true if I change this to be very blue. Then I will have a lot of blue brightness. And it's kind of hard to get exactly all zeros everywhere. But also, I can't really tell the difference between like any of these colors in here, so I don't really know what's going on. And there's probably a way to get a lot of green brightness as well. So there you have it. That is very green, according to the computer. And computers are never wrong. Something else to think about while you're looking at this, I don't know how accurate the colors are on this projector. I don't know how accurate the colors are on your screen or my screen, and I don't know what this would look like if you printed it. This is a way of describing the idea of a color, where 00, FF, 00 means as much green as you can give me. But how that actually shows up and how we actually perceive it is distinct from the numerical value. So here is how I think of these things, and I think of them really linguistically, not necessarily experientially. It's not like I go out in the world and I'm like, oh, look, it's a 0xFF0000 fire hydrant. I've never thought that, right? But sometimes I want to make, for example, the flag of Switzerland, and then I think about this quite strongly. So I think of all Fs as white, all zeros as black, 2 Fs and 4 zeros as red, 2 zeros, 2 Fs, and 2 zeros as green, and then 4 zeros and 2 Fs as blue. Why is that? The first 2 digits represent red, the second 2 digits represent green, the third pair of 2 digits, however you want to think about that, represent blue. It's red, green, blue. Why is it in that order? There's probably a good reason. It happens to be reverse alphabetical order, if that helps you remember. I simply don't remember this. I just type in a color and see what comes up. I think it might be the case that in VS Code, can I do this? Let's see. Is this going to like know it's a color? So if you're using VS Code can read your mind and tell you what color you're looking at. And I think you can even click this and then just use the built-in color picker. So if you're into that, go for it. That's actually ridiculously nice, right? So that is one way to deal with colors. So what are we going to do with this? I have this problem I'm trying to solve, and this problem is that I want to make cool looking stuff in PGL. So in order to do that, I'm going to start trying to write programs that create colors, and then I am going to look at the colors in PGL. So conceptually, I have the brightness of 3 colors. I'm going to express it in hexadecimal, and then I'm going to keep it from 0x or 0x00 to 0xFF. There is one thing going on, which is that if I take, I don't know, if I try to do like print int of color, PGL expects to receive colors in this hexadecimal format, where they are octothorpe prefixed with capital Fs, and Python expects to receive them in this format. And I think I have to tell them it's in base 16. And then it might work. And maybe this works if I say 16. Let's see. So I can't use the octothorpe prefixed PGL numbers with the Python 0x prefixed hexadecimal numbers. Why is that? Don't ask me. I neither designed Python nor PGL, right? I thought we should just not let students use decimal numbers at all, and that was really unpopular, mostly with the students. So this is not necessarily the easiest thing in the universe to deal with, but let me just guide you through a process of something you can do with this that I think is interesting. So let's just look at a simple example. I'm going to run this in my browser, and then I'm going to load up the code, and we're going to take a look at what's going on here. So I'm going to press run, and I'm going to see these bars of color sort of migrating across my screen. What is going on there? Oh, that's a lot of nonsense. Okay. So from PGL, I'm importing everything. I'm only using Gwindo and Grect, but that's fine. I am creating a list of 4 colors: white, red, green, and blue. I am creating a graphics window of size 400 by 400, and I'm setting a counting value. I'm starting at x equals 1 or x equals 0, and then I'm going to loop over the colors. For each color, I'm going to create a Grect that's going to start at the x location, which will change over time, and it's going to start at the top of my screen. It's going to extend 100 units across the top of my screen, and it's going to extend 400 units down my screen. I'm going to set that rectangle to be filled. I'm going to set it to be a color. I am going to gw.add that rectangle, and then I'm going to increase the x value. Let's go ahead and take a look at this. There we go. There we have it. This might be a little non-obvious what's happening in each step. So we can actually do one better. I'm going to put x inside of the graphics window. I'm going to unpack it from the graphics window everywhere I used it. And I'm going to just verify that this code works quickly. It does. And then from here, what I can do is I can, instead of saying for color in colors, I can say for I in range length colors, and then I can set the color to colors I, which is just another way of referencing the values in the list. I don't actually have to do colors I can also do x divided by 100 because I'm increasing x as well. Is that one going to work? That one's not working. Oh, it has to be gw.x, sorry. So this is still working. This can now be a event, and I can gw.add event listener, click event. And then I think I can add the colors one at a time. I did not mean that. Oh, I have to define it first, right? We'll just grab this. This event is going to that. Should I call it something other than event? Like, you clicked. I don't know. You clicked. Okay. And from here I can click and add colors one at a time. Let me demonstrate that again. I'm creating my graphics window. I am adding colors one at a time by clicking. These might be small and annoyingly small. No problem. I'm going to increase my window size by setting it equal to 400. I'm going to replace all of my 400s with W. And then I'm going to replace this with W divided by 4. W divided by 4. Whoa, that is not what I meant to do. I'll replace this with W divided by 4, and this with W divided by 4. Oh. See if I can get this to work. Please work. No, okay. Where's my error coming from? Oh my gosh, it's so much nonsense. Okay. That's x divided by W divided by 4. Oh, it's right here. Yeah, thank you. Please work. Oh my gosh, there's so many windows open. Okay. There we go. And I can click across. And maybe changing that to W is super annoying for you, but watch, I can change it to 1,000 now. And it's just even bigger, and that's kind of cool. I'm putting this code in Discord in case you think it's interesting. Okay. Oh my gosh, where's the... Okay. Where do we go from here? Well, from here, I'm going to use string operations to create the appearance of different types of colors. How am I going to do that? Well, I like, as a rule, to express my colors not necessarily as octothorpe and then 4 or 6 digits. I like to express them as a list of the red, green, and blue color. That is my preferred way to express colors. You are not required to think of colors this way, but I'm going to do this for a reason. So I'm going to create a color, or a function called toColor from RGBs, and it is going to take a list, and it is going to return a color. I'm just going to put this in here for now. So I'm going to create a function called toColor.RGBs. Now, this doesn't currently work. This is going to cause my code to explode, but if I just put a return statement here, it'll be fine, and then I'm allowed to run my code. So I'm able to test this. So what am I going to do? I'm going to get something like this, and I'm going to try and make a hex code like that. So what's the first thing I'm going to do? Well, one of the first things to do is take my 3 numeric values and convert them to hex. I wrote this with a list comprehension, which I taught us at the end of last week. I'm going to rewrite it now in front of you into just a standard list operation. So we can just take a look at this. For brightness, I like to call the 3 values the brightnesses because that's how I think of them. In RGBs, print hex brightness. And what am I going to do here? Kind of losing interest in this. Let's see. Well, it's not very exciting. We'll come back to this. It'll be fine. Okay. Let's do a print. Oh, I'm printing them already. So we'll just say 2 color of turn 55, 100, 0. Will this work? No, because I expect to get the 3 colors in a list. So I'm going to get them back if I do this. RGBs is not defined. Oh, sorry, I called them Ruth Bader Ginsburg's by accident. I often do this. It's Ruth Gator Binsburg. You got to remember it. Okay. And so what am I seeing here now in the console? I'm successfully printing out 0xFF, 0x64, and 0x0. I need to turn this all into one hex string, so I'm going to create my string, which is going to be equal to, I'm going to octothorpe prefix it, and then I'm going to add the hex value at each point. When I do this, I will not see anything pop up here because I'm not printing anything. So what I need to do is I need to print 2 color. I'm encouraging you to pay attention to what I'm doing right now because you will do this wrong and then be frustrated and annoyed. What I'm doing is I'm doing the difference between printing and returning strings. So when we look at this code, this will not print anything because there's no print statements. I might think, I was writing 2 color, so I should print 2 color, and I will see none because I have a return statement in 2 color, but I am not returning the string I created. So I have to return S and print S. But if I do not print 2 color, then I still do not see S. Earlier this term, I got a variety of questions about why you would care about the difference between printing and returning. This is why. It suddenly matters, right? And it mattered the whole time, but you could kind of get away with it earlier. This is not a well-formed hex value. It's actually terrible. And so, what do we need to do with this? Well, here's how I'm thinking of it. We need to get rid of all of these x's. I have 3 x's. And then I need to make sure I have exactly 2 digits of everything. So how am I going to do that? Well, I'm just going to use string operations because I'm working with a string. So the first thing I'm going to do is I'm going to replace that x with a 0. Why a 0? Well, I don't want to add or remove any color, so I'm just going to throw some zeros on the front of it. And when I do this, I get in a lot of trouble because you can't just put 0 in strings. I have to provide it the string 0. And then I'm able to make a replacement, and we see now we're getting to something perhaps that looks awfully close to us. We have the FF, the 64, and we have the 0. But this needs to be a 6-digit hexadecimal string, so we cannot have all of those leading zeros at the beginning. So what are we going to do? We're going to take the last 2 digits of this value. This might seem kind of crazy. So I think I'm going to start 2 from the end and then go to the end. And that's going to give me back 2 digits from each of the colors. If this looks odd to you, it's not too bad. Just look at what happens if you take 1, where it takes the last digit, or 3, where it keeps a leading 0. The reason I have to do this slicing is because I have different numbers of digits for each color. These first 4 digits represent FF. These next 4 digits represent 6-4. But this is only 3 digits here, because that represents 0. So if I have a single digit value, I don't have enough if I only take, for example, the first 2. Or I don't know how I would take. How do you take the first 2? Like this? Those are all zeros, right? And they're all different lengths if I don't take the slice. So I'm going to take the digits beginning 2 from the end by going back 2 and then reading to the end of the string. Let's make a window. Let's make it size W. And let's make a Grect. We'll call it R. Grect, we'll make it size W over 2, W over 2, W over 4, W over 4. Okay? We're going to set the fill color, or we're going to set the color to color of, someone say a number you like between 0 and 255.
96.
96. Can I get another one?
188.
188. And any third numbers between 0 and 255?
13.
13, great choice. Is this code going to work? This is a trick question.
I mean, yes, but you're not adding them, so they're not making sense.
Ooh, that's close. It's worse than that. This was the example of what you cannot do earlier, which is that you have to provide these as a list.
Oh, yes.
I know you thought I was bamboozling you, but in fact there's only one argument here, right? So if I put 3 arguments in here, Python will get mad at me. Specifically, it will say, I wanted one thing and you gave me 3 things. Now, if you're completely locked in and you know you can understand this error statement, you're not in trouble now. But otherwise, you're in big trouble because you would have gotten bamboozled, right? Now, I want to reiterate, I'm not trying to bamboozle you. I'm just annoyed that 2 different parts of Python express hexadecimal numbers in a different way, okay? This is understandably annoying. Okay. Oop, I think I have to do this. Okay. All right, that's not that bad, right? Wait, the window, it defaulted to doing, okay. So I only provided 1 dimension to the graphics window and I assumed it'd make a square. It didn't, it made a rectangle. I don't know how it decided how tall to be. So I'm gonna give it 2 W's. That's twice as many W's as we started with. Okay. So I think someone said something that I should GLAD it. Is that? So now it'll work. It's not filled. We didn't fill it.
And then you need to set filled to true.
Oh my gosh, we have to go to Philly. Wait, is it like this?
Yes.
Okay. What did we as a class independently develop something that is very close to olive drab? It's a sign.
It's like a magic trick.
Yeah, I mind controlled you all into creating olive drab.
I don't think it was you.
No, it was. Thank you for giving me credit. Okay,
So you admit you like all of that.
that's not what I admitted. I have to say it looks much more olive drab on my monitor than it does on the projector.
I'm
So
just saying, I think somebody else controlled us to make olive drab.
I think I'm definitely the cult leader here. Maybe there's like a separate prophet who isn't also the cult leader. Whatever we do, we should not accidentally start a religion about olive drab. We should pick something cooler than that. Okay. So here's the steps we went through. You can take a look at them. I did them on separate lines here. Maybe you think this is cool. I don't know. I think the next one you might think is cool. So let's get to that. By the way, you can do this in a single line with a list comp if you want to. I'm not encouraging you to do that. Okay, so that's what we did with strings. Okay, I have a confession. I think solid colors are uggo. I think they're cringe. I think they're not at all based. And so what I did instead is I made something where the color gradually changes across my screen, so I'm not forced looking at a giant square of olive drab, right? So the way I'm going to do this is I'm going to make rectangles of size 1 by 1 pixel, the smallest rectangle I'm allowed to make. And I can demonstrate that by making a rectangle right now that is of size 1 by 1. I think these are the sizes. And this is going to be some of the least olive drab you've ever seen in your life, right? Can you even tell that there's an olive drab in there? Do you see the little tiny pixel? It looks like it's just dirty, right? But wait, hold on. I have an ingenious plan. What if I just add a bunch of those rectangles? So for example, if I say for I in range 0, 100. We just do this and that, and maybe this other thing, and then, like maybe that. So maybe we do all of it. And I don't think this will work that much better, but I think there's going to be just 100 rectangles that are all at the same place. So that's going to look the same. But I can add 1 to some of this stuff, right? So I'm just going to add an I here. And then it's going to make a line. So what I can actually do, and I think I was making this of size W by 2. Is that right? Oh, look. I'm making, it's a line. It's not quite a rectangle yet. But there's other things I can do as well, which is that in addition to looping horizontally, or perhaps maybe we want to say in the x dimension, then we have maybe this much of an offset. Or maybe we even, I mean, we can start with that, right? Let's see. So we can sort of start making our shape there. We can also loop in the y dimension. So for all of those x locations, I am also going to do a y location. I'm going to indent this again, and I'm going to add y here. And what do we say? Tell me why, right? Yeah? Okay. Backstreet's back, all right. Okay. I don't know that they're back anymore. Ooh, that didn't work. Why did my code explode? Oh, wait a minute. Is it just really slow? Oh, that's not good. If only I had expressed all of this in terms of W so I could speed it up a lot by making the screen smaller. I think you'll be fine at around W400. It'll be a little slow. So here's where I'm putting my colors in. And right now I've just manually written in 96, 188, and 13. What if I just put X in for all of those? That's kind of interesting. So my color increases in brightness as I increase in X values. And I pushed it this way because on my monitor it's that way, but it's this way, right? What happens if I change them all to Y? Tell me why. Okay. Think about what you think it's going to do. Have a thought. Thinking is mandatory. Okay, has everyone had a thought?
No.
Did I hear no? It will increase in brightness going down the screen. So, this is kind of cool. But, why can't I just do X and Y at the same time? And this is what I start thinking is a pretty good time. I'm adding red from the left side to the right side. So I'm increasing in redness across the top. Going downward, I'm increasing greenness and blueness. So at the bottom here, I'm maximally green and blue, which is cyan. At the top, I'm maximally red, which is red. At the top left, I have no brightness at all, so that is black. And at the bottom right, I have all brightness, so it is very close to white. And I bet this will still work if I change my W to be very large. So let's go ahead and close this. We'll get it closed on our first try. Let's go back up to 1,000, and let's check our watch. Oh no. It's starting over again. Not to worry, I have an ingenious plan. Please close. Please close.
Getting a little bit
Okay.
Andy Warhol.
It is true that I am frequently confused with Andy Warhol. I'm just going to make my square 255 by 255 and get rid of all these W's. I'm going to put a 0 here now, which might make this a little bit easier to see. So I'm going to turn off all of the green color. I'm going to turn off all the blue color. And that means it's going to be red going across and green going down. And it's going to be whatever the combination of red and green is in the corner, which is like... Mate, is he? Yeah. It's bright, though. It might be like yellow. Like brown in the middle, right, when it's darker, and then yellow when it's brighter. So this is what we do for fun at my house.
You make abstract art.
Yeah. You can also put like arithmetic expressions in there. So that can be kind of cool. So what's happening here? Why is there something horizontally across? Because I'm adding them together. So that's going over 255. When it goes over 255, it, I think, loops back to 0. I don't know. You can just check, right? And then it creates a different color going across. So you increase in brightness to the center line, you get darker again, and then increase in brightness to the corner. This might be too big. Maybe you don't want to split the brightness in the middle. No problem. Divide by 2. Ooh, float object cannot be interpreted as an integer. That's... I'm starting to think it might have mattered that I taught you about the difference between those two types of division. I wasn't convinced yet, but I'm starting to be. So, maybe that's cool. Maybe it's not. Who likes subtraction?
Guess nobody.
It's working very hard, okay? It's doing its best.
That's interesting.
So, I don't know. Do whatever you want. I think that's cool. You don't have to think it's cool. Here's an example. You can also print out what the colors look like, if you want to. And I think that's all we have time for, maybe? What time is it? We have 2 minutes left. You have some free bonus slides. You can display an image from a file in PGL using gimage file name. You have to gadd that. It's a gimage that you have to glad. Usually you want images to be named .jpeg or .png. It's up to you. I prefer .pungs significantly. Here is an example. If you have something downloaded called pixelexample.png, you can add it. Also, there is a built-in image scale option that allows you to scale things to the size of your screen. It occurs to me I didn't know about this because I wrote an assignment telling you to do this later in the term, so you'll find out. If you use this, I won't care. I don't care how it happens. You can also get pixel arrays back from images, and you'll use that on Image Shop. I hope you had fun looking at colors today. I wanted to teach gradients before I made you turn in an assignment of something you thought was pretty, but we couldn't do it. So if you want to make something pretty, go ahead. If you want to know how to extract these to put them on your Instagram, come to my office hours. Can I find them? I don't know how to search semesterly color studies. I posted them last year.
I'm super bad at that.
Yeah, I don't know. I post some every year.